Greetings people, my name is Lubo, and in this video we are covering a geometry problem, and this problem comes from the Crux magazine, a Canadian magazine for a lot of math problems, and this problem is number 207, and the question itself is from the 36th University of Alabama High School mathematical tournament, which sounds interesting. The issue is from 2017 and it stands: suppose that the points E, F, G and H lie in the plane of the square ABCD such that AEB, BFC, CGD and DHA are equilateral triangles. If the area of the EFGH figure is 25, then find the area of ABCD. This question is really interesting, and there are maybe a lot of different solutions. However, I will show you for me pretty easy and let's say interesting solution. So yes, the figure of the problem is as you can see it, a square. But how do we know this is a square? We can pretty easily assume it is a square because of the problem. However, I will show you a way we can prove it's a square. I'm not going to write it in details, but I will discuss the main points. So the main thing we know is those triangles are equilateral, so they all have 60 degrees on their edges, and because of that I took the upper triangle. It doesn't really matter. We can say that if these angles are 60 degrees each of them, the square has of course angles of 90 degrees, and if this is 60 as well, then this angle, which is HDG, is 150 degrees. And from that, the DGH angle is 15 degrees. But if those triangles are similar and they're all equilateral, then if HGD is 15 degrees, then CGF is 15 as well, and 60 plus 15 plus 15 is equal to 90 degrees. So angle HGF is 90 degrees. We can say that for every angle, and to prove this figure is a square, we have to prove 3 of those angles are 90 degrees. They're all 90 degrees, so this is a square, which is good. Now, when we know that those are 60 degrees, we can write that the side of the square, the big square, is 5. And every side of the square as well is 5. And what we can do now is draw a line, and this line is going to be from H to F. So the whole idea of this move is that we can use a Pythagorean theorem to solve what is this side length. And from triangle HFG, we can just say that 5 squared, which is 8g, plus fg, which is 5 squared as well, is equal to hf squared. And from that we can just say, I'm not going to write it in details, hf side is 5 times square root of 2, which is great, because now we're going to see the hf side a bit more, because there are some interesting things about this. Now let's say that the side length of the small square ABCD is equal to A. And if AB is A, we can express the HF side using only A. And how we're going to do that? Let's take the triangle ADH. And ADH triangle has a height, and this height, which we're going to say it's h, is a square root of 3 over 2 times the side of the length, which is a. And this can be applied for every side, for every equilateral triangle. So the height is going to be a square root of 3 times a over 2, which is good, because now we can state that hf is, which is equal to 5 square root of 2, is equal to 2 times, because we have h, let's say this this point is going to be q, this one, and this one is going to be p, just some points. HQ and PF are equal, so it's going to be just 2 times this side, which is square root of 3 times a over 2, plus the side length a. And from this expression we can say that 5 square root of 2 is equal to square root of 3 times a plus a, plus a. And we can express a, and when we see what is going to be, a is equal to 5 square root of 2 times square root of 3 minus 1 over 2. Which is interesting. It's not a pretty good number, however, but now we can solve the area of ABCD. So we can write S, the area of ABCD square is just this number but squared, so it's going to be 25. It's going to be 25 times 2 minus square root of 3, which is good, because now we know what is the area of ABCD. It was pretty interesting question, a short one, but the first geometry one in this channel. And if you want to say something about the problem, leave your opinion in the comments, and we will see in the next video. If you want to support me, you can like this video, you can subscribe to the channel, follow me on Instagram or Patreon if you want. And that's it from me. Thanks for watching.